What if gravity increased by just 1% every year? Tomorrow morning you wake up. Nothing looks different. Your room is exactly where you left it. Your phone is still on the table. The sunlight coming through the window looks completely normal. You get out of bed. You walk to the kitchen. You pick up a glass of water. And nothing feels wrong until you stand on a scale. Yesterday it said 70 kilograms. It says 70.7. You haven't gained any weight. You haven't eaten too much. Your body hasn't changed. Something else has. Gravity. Earth is pulling on everything 1% harder than it did yesterday. And the strangest part? Almost nobody notices. Because 1% sounds harmless. But what if that 1% happened again tomorrow? And the day after that? And every single year? Forever? This is what happens when we take one of the most ordinary forces in the universe and change it just a little every year. Year 1. Let's start with something simple. The gravity we experience at Earth's surface is about 1 g. It's the reason things fall. It's the reason you stay on the ground. It's the reason the atmosphere stays around Earth. And it's the reason your body has weight. Now imagine that tomorrow, Earth's gravity becomes 1% stronger. Instead of 1 g, we have 1.01 g. For most people, this would barely matter. If you have a mass of 70 kilograms, your mass is still 70 kilograms, but your weight would increase by 1%. You might feel slightly heavier. A jump would be slightly lower. Running would require slightly more effort. Carrying something heavy would be slightly harder. But life would continue. Airplanes would still fly. Cars would still drive. Buildings would still stand. Nobody would look outside and think, something has changed. And that's the dangerous part, because the next increase is coming. Year 5. 5 years pass. Gravity has increased every year. It's no longer exactly 5% higher, because the increase compounds. After 5 years, gravity is about 1.05 times what it was before. Still not terrifying, but now the difference is becoming noticeable. Imagine going for a run. The route hasn't changed. Your shoes haven't changed. Your body hasn't changed. But every step requires slightly more force. Every jump is lower. Every staircase feels a little steeper. And athletes notice first. A high jumper doesn't have to become weaker for their performance to get worse. The world itself has become harder to jump through. The same thing happens to almost every sport involving movement. Gymnastics, basketball, football, track and field. Even simple things like climbing. The records people spent decades trying to break. They get moving in the wrong direction. And then engineers start paying attention. Because humans aren't the only things being pulled downward. Everything is. An airplane doesn't care that gravity increased by 1%. It still has to generate enough lift to stay in the air. Its engines still have to move air. Its wings still have to create lift. And its entire structure still has to support its own weight. 1% isn't enough to destroy aviation. 5% probably isn't either. But as the years continue, the margins get smaller. Aircraft need more performance. Fuel becomes more valuable. Payload becomes more difficult. And every kilogram matters. Eventually, aircraft designers are no longer designing for the Earth we grew up on. They're designing for a planet that is getting heavier. From the perspective of everything standing on it. Year 10. 10 years. Gravity is now about 1.10 g. That doesn't sound insane. But remember what this means. A person with a mass of 70 kilograms still has a mass of 70 kilograms. Their body didn't magically gain 10 kilograms, but their weight is roughly 10% higher. Every step, every jump, every object they lift, every machine that moves, every structure that supports itself, everything feels the change. And now something much bigger begins to happen. Civilization starts adapting. Cars become lighter. Machines become more powerful. Buildings are designed with larger safety margins. Aircraft become more efficient. Robots take over jobs that require moving heavy objects. And governments begin spending money on a problem that didn't exist 10 years earlier. But there's another system that gravity controls. One that covers the entire planet. The atmosphere. The air above US. Earth's atmosphere doesn't simply float around the planet. Gravity holds it there. The air near the surface is compressed by the weight of the atmosphere above it. And as gravity becomes stronger, the atmosphere becomes more vertically compressed. The exact climate response would depend on temperature, atmospheric composition, and how our imaginary increase in gravity is produced. But one thing is clear. The atmosphere would not behave exactly the same way. The height of the atmosphere would change. Pressure with altitude would change. Clouds and weather systems would operate in a different gravitational environment. Even mountains would have a different relationship with the air above them. The sky would still look blue. Birds would still fly. Clouds would still form. But the physics underneath them would be changing. Slowly. Silently. Every year. Year 20. 20 years have passed. Gravity is now about 1.22 g. And this is where the experiment becomes serious. Imagine someone who has spent their entire life living under normal gravity. Now put them in a world where everything effectively weighs about 22% more. Walking is possible. Running is possible. But physical effort has increased. Jumping becomes harder. Climbing becomes harder. Lifting becomes harder. And the human body isn't the only thing under stress. Infrastructure is feeling it too. A bridge that supports thousands of tons doesn't suddenly become stronger. A skyscraper doesn't gain extra steel. A crane doesn't magically gain more lifting capacity. The world is asking every structure to carry more. The first things to disappear. But here's where our story becomes interesting. The world probably doesn't collapse. Not yet. Instead, things become uneconomical. Some buildings stop being worth maintaining. Some types of aircraft become obsolete. Some forms of transportation disappear. Some industries move underground. Some cities redesign themselves. And some things simply stop being built. Humans are incredibly good at adapting to slow changes. If the world changes overnight, we panic. If the world changes over 20 years, we invent something. We build something. We redesign something. We move somewhere else. We adapt. But gravity is still increasing. Year 25. 25 years. Gravity is now about 1.28 g. That's almost 30% stronger than where we started. Now imagine a child who was born on the first day of this experiment. They have spent their entire childhood in stronger gravity. Their world is normal to them. They don't remember the old Earth. They don't remember how easy it was to jump. They don't remember people running faster. They don't remember enormous skyscrapers being everywhere. To them, this is simply Earth. And this creates a strange possibility. Humanity wouldn't only be adapting technologically. Over extremely long periods, biology could also become relevant. We know that gravity is an important environmental stimulus for living organisms, and researchers have studied biological responses to sustained hypergravity in animals. But predicting what humans would evolve into over centuries would be highly speculative. Maybe humans become shorter, maybe stronger, maybe more compact, or maybe technology prevents most biological adaptation entirely. We don't know, but we can keep increasing the gravity and see where the physics takes us. Year 50. 50 years. Gravity is now about 1.64 g. This is no longer a world that looks like ours. Imagine carrying your own body through a normal day. Your muscles have to work against much stronger gravity. Standing becomes more demanding. Walking becomes more demanding. Climbing stairs becomes exhausting. And physical activity that was once normal becomes something people need to prepare for. Technology becomes essential. Powered exoskeletons become more valuable. Robots become more common. Buildings become shorter. Transportation becomes slower and more specialized. And spaceflight? That's where things become particularly painful. Escaping Earth. Every rocket launched from Earth has to fight gravity. To escape Earth's gravitational influence, a spacecraft needs enormous velocity. If the gravitational environment becomes stronger, reaching space becomes more difficult. The exact consequences depend on what is causing our artificial increase in gravity. But under our hypothetical rule, the energy required to escape the planet would rise dramatically. And that means humanity becomes increasingly trapped. At the beginning of our experiment, space was expensive. After decades of increasing gravity, space could become almost unreachable. Satellites become harder to replace. Deep space missions become rare. Launching anything into orbit becomes an enormous engineering challenge. Humanity's technological civilization would begin turning inward. Not because we stopped dreaming about space, but because the planet became harder to leave. The oceans. And then there's something almost nobody thinks about. The oceans. Gravity affects every drop of water on Earth. As gravity changes, the behavior of the atmosphere and fluids changes with it. Ocean waves. Ocean circulation. Water distribution. Atmospheric pressure. All of these systems exist inside a gravitational field. The exact consequences would be complicated, but the important idea is simple. Earth's climate system was built around the gravity we have today. Change that gravity, and you're changing one of the foundations underneath the entire system. And we're still not finished. Year 75. 75 years. Gravity is now about 2.11 g. More than twice the original gravitational acceleration. At this point, normal human life becomes extremely difficult. A person who was comfortable standing and walking under 1 g now has to deal with a gravitational environment more than twice as strong. The human body is not designed around that environment. Movement becomes expensive. Falls become much more dangerous. Lifting objects becomes extremely difficult. And simply standing for long periods becomes a serious physical challenge. Civilization would have transformed long before reaching this point. Humans might spend much of their time in specially designed environments. Mechanical assistance could become normal. Buildings could be designed around powered transportation rather than stairs. Robots could handle almost all heavy physical work. And cities might become smaller and more densely engineered. But now we reach a question that is much bigger than technology. Can humans remain on the surface at all? Year 100. 100 years. Gravity has increased by 1% every year. It is now about 2.7 times its original value. 2.7 g. This isn't a world where you simply feel a little heavier. This is a fundamentally different environment. A human body that evolved under Earth's original gravity is being forced to operate under almost 3 times the gravitational acceleration. Standing, walking, breathing, moving blood. Every physical process is happening in a radically different environment. At this point, the question isn't, can humans adapt? The question becomes, can technology keep us alive? And there might be an answer. Artificial environments, mechanical assistance, specialized habitats, perhaps even moving parts of civilization away from the surface. But remember what happened to spaceflight. Leaving Earth has also become harder, so humanity would be trapped between 2 problems. The surface is becoming harder to live on, and escaping the surface is becoming harder too. The strangest part, But here's the strangest thing about this entire experiment. There probably isn't a single moment when humanity loses. There is no giant explosion, no instant apocalypse, no countdown reaching zero. Instead, the old world slowly disappears. First, some sports, then some aircraft, then some buildings, then some industries, then some cities. Generation after generation grows up in a world that is slightly different from the one before it. And eventually, people stop remembering what the old Earth felt like. A person from year 100 might look at an old video of someone jumping and think it looks almost impossible. They might watch people running through a park. They might watch rockets launching. They might see skyscrapers hundreds of meters tall. And they would be watching a world that feels almost alien, even though it was Earth, their Earth, just lighter. So, would humanity survive? Maybe, but probably not in the way we imagine. Humanity has survived ice ages, diseases, wars, natural disasters, technological disasters. We've survived because we adapt. But adaptation doesn't mean keeping everything exactly the same. It means changing. If gravity increased 1% every year, humanity might survive by becoming something different. Our cities would change. Our technology would change. Our transportation would change. Our bodies might eventually change. And perhaps our idea of what it means to live on Earth would change too. Because the real danger isn't 1%. 1% is almost nothing. The danger is that the 1% never stops. 1% becomes 10, 10 becomes 20, 20 becomes 50, and eventually, the planet you were born on becomes a place your ancestors would barely recognize. So imagine standing outside 100 years from now. The air is different. The buildings are different. The machines are different. The people are different. You look up at the sky, and somewhere above you is the moon. Still there, still orbiting, still familiar. But getting there has become almost impossible. Then you look down at the ground beneath your feet, and you realize something. The Earth didn't become hostile overnight. It didn't explode. It didn't burn. It simply became heavier. 1% at a time. And maybe that's what makes this thought experiment so disturbing. The most dangerous changes aren't always the ones that happen instantly. Sometimes they happen so slowly that you have enough time to get used to them. Until one day, you realize you're living in a completely different world, and you don't even remember when it changed. This is After Zero. What should we change next?